An important threshold has been breached, not just for astronomy, but in the search for extraterrestrial intelligence, and that is the threshold of 5,000 confirmed exoplanets. Now remember, the first confirmed exoplanet wasn't really truly confirmed until the mid-1990s, and now we're up to 5,000, and this number is rising exponentially. Now for those not familiar with exoplanets, you may want to look at my exoplanets tutorial, which you'll find in this video up here. But for those who have seen that already, the discovery of exoplanets is in fact an exponentially rising data set because it is a function of the exponential progress of computing. So I'll explain to you why that is and what that means for the future, as well as for the possibility of when we might expect to find extraterrestrial intelligence or be able to say with some certainty that it's a relatively uncommon thing in this galaxy. So first off, we go to the chart of exoplanet progress. This is the chart of cumulative exoplanet detections per year, very current, May 26, 2022. And as you can see, virtually nothing was discovered at all until the mid to late 1990s, and this is a linear scale, not a logarithmic one. And as methods of detection rose, the number of exoplanet discoveries increased a lot as well. Now it is up to 5,000 and rising on this curve, and it's only choppy because it's dependent on a small number of missions such as the Kepler Space Observatory and others, but now more and more telescopes are being launched, so this curve will smooth out because multiple types of spacecraft will be looking at exoplanets in a variety of different directions and through a number of methods. So we're up to 5,000 here based on this chart. And this leads me to an article I wrote on The Futurist long ago, 13 years ago. So we go there next. This article that I wrote on my old website, The Futurist, was titled SETI and the Singularity. And I wrote this a long time ago. I'll show you the date. The date I wrote this was May 23rd, 2009, so 13 years ago. And I will do a detailed video about this article in the future, but here's one thing to look at, the exoplanet discovery rate. I'll highlight this over here. As of May 2009, we have now confirmed a total of 347 extrasolar planets, with the rate of discovery rising quickly. So as we saw from that chart just a minute ago, as of 2009, there were only this many exoplanets, 347. Now there are more than 5,000 discovered, and yet we have not found any evidence whatsoever of extraterrestrial intelligence. The evidence is notable for its absence. There's truly zero. It is exactly the same amount of evidence as there was in 2009 and as there was in the 1990s and for centuries before that. Zero. None whatsoever. And in summary, I'll show you the thesis of this article. And this article is not the central source for this video, but 4 postulates. The expected lifespan of an intelligent civilization is rising. Telescopic power is rising quickly, possibly at 26% a year. I in fact did a whole video about that on this channel, which you can look at in this tile up here. Thousands of planets in the life zone will be confirmed by 2025. I'll elaborate upon that next. And a civilization slightly more advanced than us will soon be easy for us to detect. And then I put my conclusion in this box over here. And remember, this was written in 2009. If we do not find any evidence of extraterrestrial intelligence by 2030, then we can confirm with some certainty that such civilizations are not as common as the proponents had hoped. Additionally, each subsequent year without a discovery makes the probability exponentially less likely. Now that was quite a thing to say from 2009, but now we're much closer to 2030. In 2022, we're only 8 years away from 2030, whereas I wrote this when we were 21 years away from 2030. And we have no evidence whatsoever of extraterrestrial intelligence, despite so many more exoplanets being found. Now what does that mean? Is that enough of a data set from which to draw any sort of conclusion? Well, no, 5,000 planets is still very little. There are over 1 trillion exoplanets in the Milky Way galaxy, and probably 10 billion or more on which liquid water can exist. So we have only discovered a very, very tiny fraction. However, the progression of technological trends leads us to be able to estimate by what time we will have searched a significant portion of the galaxy. So for that, we go to a computing progression chart. Now what we're about to see is one of the most profound subjects that we can possibly consider. We are fusing the search for extraterrestrial intelligence with the progress of computation and the possible rise of artificial intelligence. This is just about the most advanced subject any of us could ever talk about. So if you've made it to this video, congratulate yourself because you're one of the big thinkers, and the small amount of traffic that this video has received itself reveals how few such people there are in this world who can think about such profound subjects. So I go to the computational chart. Now this chart I have revealed in other videos where I spoke only about supercomputing progress. You can look at videos like that in the tile up here in the upper right hand corner. This is supercomputing teraflops, and in 2009 I didn't think we would deviate away from the trend line. I wrote that SETI in the singularity article over here, and since that time supercomputing has deviated from the trend line. And that is why we have found only 5,000 exoplanets to date rather than something like 15,000, because the discovery of exoplanets rises as a square root of the increase in computational power. Why is it the square root? Because as the size of each pixel becomes half, you get 4 times as many pixels per the same area. And therefore, to get an increase in resolution, you have to have a rise in computing power that is a square of the increase in resolution. So if computing power increases 100x, then telescope power increases 10x. I hope that was clear, but look at that telescope video that I had in a tag earlier in this video for further clarification. So right now, we are at 5,000 exoplanets because computing is around here. If it were back of the trend line, it would be 15,000. But that detail isn't actually all that important because I know we will revert back to this trend line before too long, just because the pressure to revert is very high, as per that video that was in the tag a moment ago. Therefore, by 2030, we'll be over here, and the number of exoplanets discovered will be somewhere between 100,000 and 1 million. That is starting to become a large number and a non-trivial fraction of exoplanets in the galaxy. But fine, if you think that is still too small of a data set, go to 2040, around here, where we might have discovered millions of exoplanets by then. And then suddenly we have a statistically relevant sample size, and if we have found no evidence of extraterrestrial intelligence at all, even by then, when we have in fact searched a significant fraction of the galaxy, we can start to assume that extraterrestrial intelligence is not as common as was initially thought. If you harken back to the Star Trek franchise, first contact with an extraterrestrial intelligence occurs on April 5th, 2063. Under very different circumstances, though. It was not because of telescope discovery, it was because of humans figuring out how to travel faster than light.
Western Hemisphere, North American continent. It's like a missile complex in central Montana.
Missile complex.
The date. I need to know the exact date.
April 4th, 2063.
April 4th. The day before first contact.
Precisely.
Then the missile complex must be where Zephyr Cochrane is building his warp ship.
That's what they came here to do. Stop first contact.
What is happening here is as we progress through the decades, and this is happening very soon now, we're talking the 2030s and 2040s, it will be harder and harder for large numbers of extraterrestrial intelligences to remain undetected if they are all that numerous. In the Star Trek franchise, they present a galaxy where intelligent civilizations are found every 10 light years in all directions. Every 10 light years you go, you'll find an intelligent civilization. That is clearly not the case so far. And yes, there's too little data that we have available to us in 2022, but by 2030, 2040, perhaps even later, 2050, we will have searched much more of the galaxy, and if we haven't found anything by then we can very safely conclude that extraterrestrial intelligences are very uncommon. We may even be the most advanced in the galaxy. I wouldn't go that far yet, but there is a chance that we are the most advanced within at least this section of the galaxy. Because the accelerating rate of change complicates all existing thought around SETI, because it's very difficult for a civilization to be much more advanced than us and still be hard to detect under the accelerating rate of change. Remember, we did not know of any exoplanets until the mid-1990s. Now we have 5,000, and within a decade and a half or two, we'll have over 1 million exoplanets discovered and cataloged. And therefore, the fraction of the galaxy that has been searched rises, and as big as the Milky Way galaxy is, eventually when you have searched 5, 10, 15, 20% of it, and if there is no evidence of extraterrestrial intelligence, you can make some extrapolations from there. When Carl Sagan was relaying the Drake equation in 1980 in his Cosmos television documentary series, that was when one could plausibly guess that there were thousands upon thousands of extraterrestrial civilizations broadcasting messages in the frequency bands we were searching, because there was just no way to disprove that in 1980 under the technology of the time. But since we have searched that frequency quite extensively, it's at least not as common as some people thought. And so let's see what happens in these coming decades. I say that we are probably one of the few intelligences in our galaxy, or at least the most advanced, because the accelerating rate of change will eventually preclude the possibility of there being many, many, many civilizations that are equal to or more advanced than us. It's still too early to say, as I said, but by 2030, just like I wrote in my article, that is when we will begin to see how uncommon extraterrestrial intelligence is if we have not found anything by then. Of course, I'll be wrong when we find something, but I suspect that advanced civilizations are fewer and further between than a lot of people think. And as we get to a technological singularity, which I estimate to be around 2062, give or take a few years, that coincidentally is around the time by which we will have been able to map most of the Milky Way galaxy and most of the exoplanets, at least in our half of the galaxy. Not on the other side, perhaps, but at least in our half. And if we don't discover anything by then, well, that tells us something. So this is a very, very advanced topic. I'll do other videos about this. This is not a high traffic topic, sad to say, but I have an obligation to make videos like this because too few people are discussing this all-important topic. But if you find this type of subject to be interesting, I encourage you to subscribe to this channel, and thank you very much for watching.